me explain a program of ARM processor to solve an expression like cx square minus 9x plus 2. So here I need three segments. Three segments are initialized. Why three segments required? In one segment I am going to store the input. Another segment I am going to store the result that is expected out after the execution of the program. Then the third segment where I am going to write the program. Let me see how am I going to create the segment. I am going to use some assembler directives. Why do I need assembler directives? They are the instructions to the assemblers. Why do I need assemblers? Because I am writing the program in assembly level language. Assembly level language in the sense the instructions are going to be in the symbolic form. So let me take up the first segment which are in the blue color. Area is an assembler directive which enables me to take a block of memory which is called as a user defined name of my choice. I have used data 1 where I am going to use the data. I am going to store the data and I have preferred read-only type of memory. So area, data and read-only are the keywords. Area represents the assembler directive to provide me a block of memory. Data is an assembler directive which will enable me to store the data. Read only is the assembler directive with which I can choose a memory of read only or permanent type. Now I have used x equal to 3, p equal to 6, q equal to minus 9, s equal to 3 because this equation there are 6x minus 9x 2 and all which have used EQU directives to define some constants with numerical values. So this is one segment which I have called as data 1. That segment exists in read only and that segment consists of only data. So I have used the assembler directive as data. So data 1 is the segment which is created for me using a block of memory with the assembler directive area. Then another segment is there where I have chosen answer as the name of that location, have reserved define constant byte is the assembler directive with which I can reserve a byte of location where presently I have filled up with 0. If not DCB, I could have had DCW where I could have reserved 16-bit location. Otherwise, I could have had DCD, define constant double word, so that I could have reserved 32-bit of locations. Here, answer would be anyways 1 byte, so I have reserved 1 byte of location which is filled up with 0 using the assembler directive called as define constant byte. Here, one thing I should observe is all the labels like X, P, Q, S, area, and then here also label comes, have to start from the first cursor position. Even A has to come from the edge. That is because, as you can observe, labels do not have a colon. To identify for the assembler that they are labels, they are identified by beginning them entered in the first cursor position or at the edge. Now I will write the program. So I need another segment. So I start the segment with area assembler directive once again. I have given the name of the segment as PGM1 and I am going to store instructions here. So code, then followed by read only. So code is written in the type of memory called read only. Here data is also written in type of memory called read only because these information I want to have them permanent. I need not enter it again after the execution, after entering the program. So I have made this permanent, whereas read write is the type of memory I have used here because answer will arrive after the execution of the program. So data, the answer that comes have to have a temporary memory so that I can easily enter the answer. Here I have done some initialization. That means X have put to R0, P that is nothing but 6 has gone to R1, Q that is nothing but -9 has gone to register R2, S have taken it to register R3. These are the pseudo instructions by which I can transfer numerical values to registers. So though I have shown X here, 3 will be entering R0, 6 will be entering R1, instead of Q -9 will be entering register R2, instead of S 3 will be transferred to R3. Now I have taken values into those registers. Why have I taken the data values to registers? Because ARM processor execute on the data which are present in the registers. So I have taken those numerical values to different registers. Now I have to start with X being multiplied with itself, X square. So R0 has got X. So R0 into R0 stored in R4. So R4 is equal to R0 into R0 means X into X, X square. I have taken value of X as 3 here. So 3 square, 9. So out of first instruction of multiplication, R4 gets 9. Then followed by that, R5 is going to be the register where R1 and R4 are multiplied. R4 has got 9, that is X square is there in R4. R1 has got, what has it got? P. P means 6. So 6x square, 6. 6 in R1. R4 has got X square. So 6x square will be stored in R5. So R5 is equal to 6x square. X square is 9. 9 into 6, 54 will be there in R5. So 6x square now arrives in R5. Now I have to do -9 into X. -9 is in Q. Q is available in R2. Then X is once again available as 3 in R0. So R0 and R2 are multiplied. -9 into X minus 9X will arrive into the register R6. These are the two inputs and this is the output. So R6 is equal to -9 into X. Otherwise -9 into 3 -27 will be there in R6. So R5 has got 6x square. R6 has got -9x. So we are going to add R5 and R6 because we are adding 6x square plus of -9x. So add R5 and R6 and store it in R7. So R7 is equal to 6 into 3 square, that is 6 into 9, that is 54, minus 9 into 3, that is 27. 54 minus 27 is equal to 27, that will be available in R7. So 6x square minus 9x, that is nothing but 27, will arrive at R7. Now this R7 value, that is 6x square minus 9x, has to be added to 2. Where is 2? Sorry, I have written it wrong. This is 2 actually, because 2 is here. So the value 2 will go to R3. So that is R7 has got 27. R3 that has got 2. 27 plus 2, it becomes 29. So R8 has got 29. But 29 will not be displayed because this is an hexadecimal number system followed processor. Because processor only follows binary. Hexadecimal and binary, they are equivalent to each other. So instead of 29, as you can see, this is how the conversion takes place. 16 ones are 16, 13 is the remainder, 13 is nothing but D. So answer is 1D. So R8 will not have 29, instead it will have 1D. Now 1D is the answer which is now in R8. Have to store in the location called as answer. How do I do it? I have to point at this memory location. I'll point at this memory location by using the instruction once again LDR, load register R9 comma equal to answer. Wherever this location is, its numerical value of the address goes to R9. Now R9 points to this location. Where is the answer? It is there in R8. So store the content of R8 into the location pointed by R9. R8 has got the answer 1D. It will go to the location pointed by R9, in the sense R9 is pointing to answer. This is the location where you have reserved a byte of location filled with 0. 0 will be replaced by 1D. And here be here, this instruction branches to the same place repeatedly. It goes to the infinite loop. That is how you normally conclude a program. End is the assembler directive which will conclude the text of the program. See, entry here is an assembler directive which begins the text of the program. End is an assembler directive which will conclude the text of the program. Here you should observe str, this instruction is actually the store instruction, whereas these are not actually the LDR instructions, they are actually the pseudo instruction. The load and store happens only between a memory and the register. As you can see here, R9, though it is a register, it represents a memory location called as answer. R8 is the register. So transaction is taking place between a register and a memory location. Then it is store. Whereas as you can see, X, P, Q, R, they are not actually the memory locations, they are the data. So these are the pseudo load instruction. This is the real store instruction. So that is what the explanation of the first program of ARM processor in the lab of 5th semester ENC. Thank you so much.